Today, we're going to pull back the curtain on computer science. We're going to show you how it's not some scary, complicated thing, but actually a fundamental part of our lives, from the moment we're born to our later years. Forget the geniuses in labs. This is about all of us, woven right into the fabric of our daily routines.
So let's get this out of the way first. Is computer science really just for a select few super geniuses? That's probably the biggest misconception out there. The truth is, you're already using its core principles every single day. You just might not realize it yet.
You know, at the very heart of all of computer science is one simple but incredibly powerful idea: the algorithm. And don't let the word scare you. All it is a recipe. Seriously, it's just a set of step-by-step instructions to get something done, whether that's tying your shoes or tackling a huge financial problem.
Let's stick with that recipe book idea, because it's perfect. Some recipes are linear, right? You just follow the steps in order. 1, 2, 3, done. Others are conditional. If you're out of sugar, then use honey instead. And some have loops. You keep stirring until the sauce is thick. See? Linear, conditional, loops. You're already thinking like a programmer.
All right, so here's our game plan for this journey. We'll start with this recipe for everything. Then we'll see how it shapes young minds. After that, we'll jump into its role in our adult lives, see how it connects different generations, and we'll wrap it all up with a final thought to chew on.
So let's dive right in. Section 1, the recipe for everything. We're talking about the universal language of logic.
Let's talk about a really key concept called abstraction. The best way to get it is to think about a car, right? All you need to know is how to use the steering wheel, the gas pedal, and the brakes. You don't need to be a mechanic who understands every little detail of the engine's combustion cycle. That engine is a black box, and software is designed in exactly the same way, to hide all the crazy complexity so that anyone can use it easily.
And once you start looking, you'll see these real-world analogies for computer science concepts everywhere. An algorithm? It's just a recipe. A class in programming? Think of it like an architect's blueprint for a house. An object? Well, that's the actual specific house you build from that blueprint. And networking? It's basically just a digital post office, sending little packages of data to specific addresses around the world. All right, now let's rewind the clock a bit and see how these ideas get planted in our brains when we're young. Welcome to Section 2, Building Blocks for Young Minds. This is where we get to something called computational thinking. Now, I know it sounds super technical, but it's really not. It's just the skill of looking at a big, messy, complicated problem and breaking it down into smaller, bite-sized pieces that you can actually solve. Think about it. How do you actually make a sandwich? You don't just magically make a sandwich. No, you follow a very specific sequence of steps. Get the bread, get the peanut butter, get the jelly, spread it, combine it. See? By teaching kids to think this way, we're not just teaching them how to code, we're giving them a powerful, structured way to tackle any problem life throws at them.
And what's so cool is that today's tools make this incredibly fun and accessible. Instead of typing out lines of frustrating code, kids can just drag and drop visual blocks to create animations or make music. And with things like robotics, they can write code that makes a real-life robot move. That makes the connection between logic and a real-world result totally unforgettable.
Okay, let's fast forward to our adult years. This is Section 3, where we look at technology in our daily lives. Everything from the powerful tools we use at work to the personalized entertainment that fills our evenings. So, here's a question I bet you've asked yourself. How does Netflix know exactly what I want to watch next? You finish one series and bam, there's the perfect recommendation. It feels like magic, right? But it's actually a really powerful application of computer science called a recommendation system.
Well, here's the secret sauce. These systems learn about you from two different kinds of data. First, there's explicit data. That's when you straight up tell it what you like by giving a show a thumbs up or a 5-star rating. But the real power comes from implicit data. What you watch, what you search for, even how long you watch it. The system takes all those little clues and builds a digital mirror of your tastes. And it gets so good, it can often predict what you want before you even know you want it.
And it's not just movies. This same kind of smart tech is what makes modern video games feel so alive. AI can adapt the game's difficulty in real time to keep you perfectly challenged. It makes computer-controlled characters feel dynamic and unpredictable. It can even generate entirely new maps and quests on the fly, meaning you could play the game forever and never have the same experience twice. So let's move on to our next chapter, Section 4, Connecting Across Generations. Here we're going to see how technology provides connection, safety, and brand new opportunities for seniors. You know, learning new tech at any age can be tough, but it can be especially frustrating for older adults. And that's why empathy is absolutely the most important tool. Just acknowledging that, yes, this is difficult, and reinforcing that learning anything new is hard, but it gets easier with practice, that's the key to building confidence. And if you're ever helping an older relative with their new phone or tablet, some of the best advice is actually pretty simple. The main idea is to connect the tech to what they already care about. So show them pictures of their grandkids on Facebook before you even try to explain how to set up an account. Use analogies they get, like a web address is like a street address. And most important of all, let them do the clicking and typing. It builds that crucial muscle memory and confidence.
And this technology goes way beyond just convenience. For many seniors, AI is literally a lifeline. Smartwatches can now detect if someone has a fall and automatically call for help. Voice assistants let them send a text or schedule an appointment just by speaking. And telehealth provides crucial access to doctors right from their living room, which is a huge deal for promoting both independence and safety.
And look, the impact here isn't just social. It's also a huge economic driver. On average, a college graduate with a degree in computer science can earn about 40% more than their peers. That's a massive difference. It's a field that offers not just fascinating challenges, but real, tangible security and opportunity throughout your entire life.
Okay, that brings us to our last section. Let's zoom out and ask a bigger question. What does all of this really mean when you get beyond the ones and zeros?
Here's the big takeaway, the thing I really want you to remember. Computer science isn't really about machines. It never was. At its core, it's a powerful toolkit for structured thinking. It's about taking pure logic and applying it to solve real, messy human problems, from loneliness and safety to entertainment and connection.
And the scale of this kind of problem solving, it's just mind-boggling. Just look at e-commerce. In only 4 years, it more than doubled to over $4 trillion. That is the engine of the modern global economy, and it's built entirely on the principles of logic and process that we've been talking about. So, I want to leave you with this one final thought. We've seen how this language of logic shapes our world, from childhood to our senior years. So the real question for all of us now is, what's next? If this is the most powerful problem-solving tool humanity has ever created, what bigger, more meaningful human problems should we point it at now?